Okay, thought I'd do a bit more of this thing here. um, See, kind of added some tests and stuff like that. Let's try out how I want to organize the data in a kind of linear table, um, with no like sub data graphs or local data. I would say because in some languages you're able to have data within data. I think even something like Haskell, you could probably have that as well. Um, but in Ray, there is no. We're trying to make it as declarative as possible. Things like identifiers and stuff like that should be matched inside the function, and if possible, maybe we should have something like combinators and such, so that we don't have to deal with variables at all. And that's probably just going to save a bunch of time as well. So if you have something like map a, and you want to apply a function to that, you can see the a is actually quite redundant, right? Because if f takes in one argument and you're mapping over one data point or one kind of item with already one, you don't exactly have to specify that, right? You could easily do just map f. I don't know, if you're looping over some list, and list has elements that can be represented by a. So I don't know, a list of a, for example, a1, a2, etc. That's just one way to do it, and all you have to do is then say, look, we'll just connect the output of that to the input of f, and kind of just do it like that. There are different things, though. I mean, maybe you want to decompose or structure. Let's say you want to decompose map into A, B, and then apply that to F. That might be a bit harder because let's say your list is like, A1, B1, B2, etc. When you do list dot map over that, you're going to be iterating over the tuples themselves, right? So if you're only going to be matching on one element, lm, that's just going to return the entire tuple, not the destructured tuple with the two elements as independent pairs. In that case, that could be a bit of an issue because it would be up to interpretation, or it might not be entirely clear what you want exactly. So maybe one way is to kind of like destructure, say like, well, two, you want to map over two elements, I guess, and over the function. That could be like a simple way of doing that. Or if you just want to, and then have the tuple applied in order, so like the first argument goes into the first argument slot of the function, and the second kind of destructured element goes into the second argument slot or parameter slot of the function. I feel like that would probably be okay for the most part. And then you could chain that again, map whatever 1, map 2, map 3, etc. And better maybe like just if it's just that common, you might as well just create a function called map2. And in Ray, you would kind of just you would define that like map2 is defined as map with 2 to partially applied to map. And map only has like one overload, to an f, n and f, I guess, n int f func. Turns maybe like a list of a result. So that's kind of like the idea. I guess it would probably be a trait or a trait function, but basically you would kind of say, look, if this is partially applied, then you just have to specify f, and maybe to partially apply you can kind of be more clear with a keyword argument rather than just a positional argument or an unlabeled argument. Yeah, I think I'm kind of leaning towards something like that. Again, I just don't want to have a language where we have a whole bunch of redundancy and just a whole bunch of bloat. Something like Haskell would be nice, I think. Although I feel like Haskell's a bit hard to understand sometimes. Mostly because the fact that it can be actually a bit too clear, a bit too kind of concise. Here, I think we're going to keep some of the traditional programming cues, like the kind of dot access operator and the parenthesized apply function call kind of operator. And there, it'll be a bit easier to kind of read, I would say, between kind of Rust and Haskell. Otherwise, you're just going to see just, stuff after stuff after stuff. You can't exactly tell whether or not you're doing something or doing something else. And Haskell is actually sometimes it actually has some methods to allow imperative programming, like the do notation. Monad transformers are essentially kind of just allows you to sequentially assign values and merge values from kind of the older values and stuff like that. Thereby you will have something that's kind of sequential. Here we don't have sequential computing. Like that's just the first thing. It's just going to be so simple. There is no BIOS. There's no extra memory mapping or any extra kind of config stuff. All the config stuff are going to be specified in file format or a declarative format, and the processing of that config file will also be declarative as well. So it's like, well, if you make everything declarative in the first place, then you don't need to have something that's going to be like, oh, step 1, do this, step 2, do this. Although you can still have procedural programming. You just don't want to have like a very low level direct programming where you're telling the machine exactly what it should, how it should do it, and not just what you want. Because again, humans are really kind of dumb, right? They make mistakes all the time. It's probably better to just state your intention in a high level. At a high level, let the compiler and stuff figure that out, and if something goes wrong you can always analyze it. So that's kind of the idea behind this kind of programming paradigm style. I think I called it hyper programming because it kind of allows you to kind of program through layers and dimensions where things are lists and tensors. So that's another thing, right? Arrays are kind of a pretty niche, pretty nice concept. A function itself can also be kind of seen as an array as well. An array that takes an argument. And just a single element, it's like a tensor of dimension 0. A usual list is a tensor of dimension 1, matrix dimension 2, and so on. Dimension 3, dimension 4, I think, are also used pretty often in places like machine learning. So and maybe scientific computing. Although scientific computing, I maybe dimension 2 or 3 at most. But yeah, PyTorch. You'd probably see if you looked at PyTorch, they use higher dimensional tensors all the time to kind of batch up data fields and stuff like that, so that they can run all at once. But yeah, I might go to the library later to do this a bit more. But for now, I think what I'm going to do is I'm going to implement. So you see, I have the function ready to kind of allow you to do some primitive add and subtract. So this is our virtual machine. We can think of this as our driver. Every function will be built upon these two kind of primitive functions. When we want to evaluate a call, we first match that, and then we go, look, we take the arguments, we collect it into a vector, and then we match the function that it's referring to, and we call it on the arguments. I might change this to value. Yeah, I might change this to value. It takes in decimal, I think. And it returned yeah, no, I'll change this to decimal. And so when we match, is it data field or data? Agent generics. Wait, why do I have an error? Oh, I have to. Oh, come on, man. Whatever, man. Yeah, I think that's good enough, to be honest. Here we're just going to return did not expect. Okay, so let's try this, I think. Okay, eval call. Oh. Oh yeah, I think we need to... God. Oh shit. Ident. Okay. Fuck. So that means I have to... Okay, so I have to basically add that and that, I guess. This is kind of a... This language is kind of annoying sometimes. One and two. I should give a reference to that. Res... Fuck, man. Can I have the macro for this? Expected ray expressions. Oh, fuck. Damn it. Okay. Maybe args. Maybe I'll just make a quick macro called args. Oops. Maybe expression. Can I do that or what? Damn it. Oh, they change it? Oh my god, man. You gotta be kidding me. Alright then. Let me think about this. Expression. Wait, how is vec defined? Oh, okay. Okay. Not really bothered to do that. I think I would rather just... Yeah, just expression like that, I guess. What, you can't do that? Maybe expression plus? What? Why, what doesn't it work? What the hell? What? You gotta be kidding me, man. What? Oh, maybe the entire thing has to be... I have to match one. Maybe just arg. And I'll match many, maybe I'll match one here. Wait, I think you have to also... Oh, there we go. Oh, was it? Good now. Good now, man. Whatever. Oops. Oh, does it not work? How do we match in? How do we match a literal? Maybe just lit? Really? Oh, just literal. Wait, doesn't it work? Or maybe it has to be... What? What's going on? This should be this as well. What the hell? Is it not... Do you have to like... Oh man, that's so annoying. Do you have to do that? Arg-TT. Sure. I think you have to do that. That's so gay. What? Format args. Maybe we have to make a macro rules arg, I guess. So gay. Shouldn't it be... Should it be this? I think so. Wait, it doesn't work? Why not? Expression literal. Man. I think I think it should work. I'm not sure. I think it might be, unless it's matching multiple. Is that what's trying to do? Missing comma. Oh. Huh? Oh, okay. What do you mean? Isn't it an expression? Oh, yeah. decimal. Okay, so that should be right then. Where's my tests? Fields effect. Do I just want to make this decimal or what? Yeah. Oh, fuck. Fuck. Empty. I don't think that's actually needed, to be honest. Yeah, I don't think that's actually needed. Need expression. Oh, damn it. I did literal. Fuck. Do I just make it call again? Call value expression. Yeah. Okay. I'm not sure if I want to how I want to do this. I think I might just refactor this so that I'm just fucking dealing with decimals for now. Then I'll add call value expression later. Did I just say int? Then int. Call value expression. Huh? Is this even used anywhere? What's the problem with this? Oh, okay. I mean, it's very expression, right? So. Oh my god. Cool. Yeah. I guess we don't need to do that right now. What we're going to do is basically deck. Okay. It's about right to me. Val. Oh, fuck. Ooh. Oh. Val. Logs. Damn it. Fuck. Damn it, I need a vec of Val, I think. Oh man. Oh wait, mute. Oh, so that actually costs it as a... Yeah, so that costs it as mute, I think. That's weird. Huh. Man, you see, this is... You can see how confusing it could be sometimes. I guess it might make sense if you look into it, but, you know, if you just want it to work, and it, you know, just works... It's not easy to just make it work sometimes, you know. Fucking hell. Right. Well, that worked, I guess. And finally. Add works. Let's try subtract. Sub. Alright. Wait, what? 1 minus 2 equals to minus 3? The fuck? Did I make the thing wrong? I don't think so. Start with 0. Oh, so I'm starting with 0, I guess. That's a bit of a problem. Okay. Damn. I mean, I guess we could just do argslot first. Can I just do that or what? Okay. So yeah, I guess it works now. Then you can kind of like build on and stuff like that, I guess. 2. Okay, nice. So, print line. Maybe I should just return parse res. Does that work? No, it doesn't work. Oh, fuck, that's annoying. Let change. Really? But I mean, you could do that with a vector, right? So yeah, you should be able to do that. I mean, oh, I might have fucking done it wrong then. You gotta be kidding me, man. It's not like they're using it either. Well, maybe they are. Jeez, look at that. Maybe let's just turn it on and see what happens. What's this one? You can noise token let in any following usage of fast and check. Okay. Fuck, that's a man. Fucking hell. Let chains. Doesn't work. Well, it's a shame, I guess. I guess we could just use a function. String s. Okay. Let's do this. Ah, fuck. Because I need the initial values, right? Damn it. Whatever. Fuck. Cool. Oh, wait, what happened? Expression. Not a valid expression. Well. Oh. Oh, okay. Man, the thing's a bit trippy sometimes. Fuck, I forgot where I fucking put it. Here, okay. Okay. No, not that one. Okay. So it works, I guess. That's kind of the main idea, I guess. And with something like APL, it's actually even better. Might look at APL a bit more because with APL, you pretty much are just applying combinators to literals and values and stuff like that. You start off with a base value and you keep transforming that. I don't even think you even need to like define a variable per se, even though like you could. But instead of a variable, I think it just becomes like a name binding. Yeah, it literally just becomes name binding. And maybe you could have like other ways to kind of jangle up the name binding, like you could hash the name into something else, I guess. So I think I don't want to have like a multi-level thing. Instead of multi-level env, hash ident and therefore you'll have a linear table. The problem is collisions, right? With collisions, you would want to either have linear chaining with comparisons or perfect hashing. So each time you're adding more things on, you're going to have to recompute entire table, which seems kind of slow, but I guess it depends, because I haven't tried it yet. But I think that could be a really nice use for it, perfect or universal hashing. In that way, we would have something that kind of just works. We could also have like, could have a combination of the ident and type, where type is either data, point, function, macro. And that way you can have like a function identifier with the same identifier as like a data struct or a macro definition. And it kind of just makes it more ergonomic to use, I would say. Another thing is, I guess, maybe shadowing. I'm not really sure how to really do shadowing. Might think about it later. Maybe we don't even have to think about shadowing. What it's good for, I guess, at least imperative or procedural programming with variables is probably something like this, where you're able to kind of go, look, you parse this, and then you parse that, and then, maybe you create an env and then env add. So it allows you to really set up the environment in a very nice, in a very kind of intuitive way, I guess. You could probably still do that with completely declaratively, but I'm not really sure, to be honest. I haven't really seen any like declarative test frameworks. There's some articles on it, like Rethinking Testing Through Declarative Programming by Javier Fernandez. That could be a cool idea. Oh yeah, maybe you could do something like this, right? You can have like you define your data, and then you kind of like chain that on a function, or apply a function to it directly, I guess. And this is pretty nice, because then you kind of have something that seems procedural, because you have this, then for each, then I don't know, map, etc. So it's still kind of procedural. It's not like imperative, as in you're telling it exactly how to do it. You're still stating at a pretty high level what you want. And that is for each kind of element to loop through each element, deconstruct that, and then apply whatever kind of function to that. Here it seems like they're kind of creating a state, and then so they do actually have a imperative block here, where they're kind of creating state and then expecting it and stuff like that. And again, I feel like that's just going to create more work for you to do, especially when you really don't need that. I would say, especially. I mean, you could just go, look, expect is a whole block, get selection to be expected, and then just to be actually not even expected, because that should just kind of slot with that. So being able to smartly compose your functions, you wouldn't even need to kind of like have imperative blocks. Even though I guess in this case it's actually okay. I would say it is kind of intuitive. But again, I just don't want to. I kind of want to do it, but I also kind of don't want to do it. So I'm just gonna see. I'm just gonna go full declarative for now, so we can kind of like just get something up. But or I don't know. Eventually, maybe get it up. Anyway, that's it for now, I guess.